Proof by induction that the sum of 2r plus 1 over r squared times r plus 1 squared from r equals 1 to n is equal to 1 minus 1 over n plus 1 squared. So the first step is to do the base case, that is to show that the statement is true for n equals 1, which means we need to look at the left hand side and the right hand side, and if the values are the same, then the statement is true. So for the left hand side and the right hand side, let's do the left hand side first, because n is 1, so that goes to 1, and we'll start from r equals 1, so that means r has to be 1, times 2 plus 1, which is that, divided by 1 squared times 1 plus 1 all squared, which is that, and that gives, this is 2 plus 1, that will be 3 over, this is 2 squared, which is 4, times 1, 3 over 4, and that's the left hand side, 3/4. And on the right hand side, we have 1 minus 1 over, this is 1 plus 1, that's 2, 2 squared is 4. This is 1 over 1, 1 over 1 is 1, and to make it the same denominator, multiply that by 4, multiply that by 4, and that gives 4 over 4 minus 1/4. Same denominator, add the numerator, that'll be 4 minus 1, that'll be 3/4, which meant that this is correct and the left hand side is correct. Therefore, the statement is true for n equals 1. Step 2. Inductive hypothesis. We assume that the statement is true for n equals k. Bring the equation back. We're going to replace n with k. That's n now equals k. We can write k instead of n. Sum from r equals to 1, the formula, and that equals to 1 minus 1 over, instead of n, we'll write k plus 1 all squared. This is what we're going to use in step 3 to now derive the next step. So we're going to use this in the inductive step in step 3. Step 3. Inductive step. We need to prove the statement is true for n equals k plus 1. What that meant is we bring back the equation and we transform n equals to k plus 1 and then write n in place of k plus 1. It's k plus 1 is k plus 2. Now this is the proof that we need to show. Now to show this proof, we need to use step 2, which is the inductive hypothesis. I'm going to write where n equals to k plus 1, which is what we're doing, and that equals to step 2 plus k plus 1 is the last time. So that's k plus 1 and k plus 2, because this is the last time. K plus 1 here will be k plus 2, and k plus 1 here squared will be k plus 1 here, and that will be k plus 1. So this is the process we now need to use, but we need to change that to k. So we're going to write the n value for that one, the sum of the n value for that one, which is with k, so that with k for step 2. And then we put in the last term there with k plus 1 over k plus 1 squared times k plus 2 squared. So this is from step 2. If we go back to step 2, this is what we're using, r equals 1 to k, which is that one, and we get that. So we've replaced n with k here. So that's what we're doing here with step 2 plus the last term. Now we need to simplify this, but if we look at where we're going, we need 1 minus 1 over k plus 2 squared. Now I just need to leave that 1 alone and work with this. This is what I need to work with, because I need that 1. So now we can carry on and simplify this. Now what I need to do is make them the same denominator. This is k plus 1 squared, this is k plus 1 squared times k plus 2 squared. So if I could multiply the top and the bottom, the numerator and the denominator, by k plus 2 squared, they will have the same denominator. So I got 1 minus 1 over k plus 1 squared plus, if I expand that, 2 times k, 2k, plus 2 plus 1, 2 times 1 is 2 plus 1 is 3, over k plus 1 squared, k plus 2 squared. Now I need to multiply both numerator and denominator by k plus 2 squared. 1 minus k plus 2 squared plus 2k plus 3 over k plus 1 squared, k plus 2 squared. So I've multiplied the numerator and denominator by k plus 2 squared, k plus 2 squared. So now they both have the same denominator. So I can make that the common denominator. So I get 1 minus, so I'm going to write this first because I did 1 plus that and then minus that. K plus 2 squared over k plus 1 squared, k plus 2 squared. So that's what I've done there. Now let's progress. If we could remember, this is where we're going. We're trying to show that using the step 2, and this is where we are. And we write that, that's the where we've got to. And what I need to do next is to write 1 plus, well, I'm going to write the 2k plus 3, then minus, open bracket, I need to expand that one. So I want to expand that on, open bracket, k squared plus 4k plus 4 over the denominator, which is a k plus 1 squared and k plus 2 squared. That will be equal to, what I need to do now is to simplify this side, because I want that side to look like that. So I need to write a plus, and I'm going to write the 2k plus 3 minus, what I've done is I open the bracket, so this is minus 1 here, minus times k squared is minus k squared, minus times 4k is minus 4k, minus times 4 is minus 4. So I just open the bracket here, divided by the k plus 1 squared, k plus 2 squared. And then now I need to simplify that. So that will be equal to 1 plus, well, by simplifying that, I get minus k squared minus 2k minus 1 minus k squared minus 4k plus 2k is minus 2k minus 4 plus 3 is minus 1 over the denominator. And now I need to take minus 1 out of this bracket to make this one plus, 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 because if I take minus out, I would get, so I'm writing that now, 1 plus, because still got the plus, minus 1 plus times minus 1, and k squared plus 2k plus 1, because I've taken minus 1 out. But if I multiply it out again, I'll get that back. Over the denominator here, which is k plus 1 squared and k plus 2 squared. Factorize that, but plus times minus is minus, say 1 minus this one here in bracket, k squared plus 2k plus 1, all in bracket, divided by the denominator. Now what we need to do is simplify this by factorizing that. If you look at k plus 1 squared, that will be equal to k squared plus 2k plus 1, and that's what I've got here. So that means that is k plus 1 squared, which would cancel that one. So that cancel that one will be 1 on top. So I'm going to get 1 minus 1 over the denominator, k plus 2 squared, because the k plus 1 squared has cancelled that k plus 1 squared. And so this is exactly what I'm looking for, and I've got that. So now we've got to the final answer, and which means that we've shown that the step 3 inductive step is true for n equals k plus 1. And that's exactly what we got, that one here. Now for step 4, the inductive statement, we need to write the 4-point statements to get the full mark. And the first one being, since this statement is true for n equals 1, we need to write that down. And if this statement is true for n equals to k, we need to write that down. Then it is true for n equals k plus 1, we need to write it down. And finally, the statement must be true for all n greater or equal to 1. All these statements must be written down to get the full mark.